All right. I'm going to mute myself here and minimize this. Okay, so let me just pull for one more time the Altman attendance syllabus. So just as a review, I think the first half of the class was really focused on the modeling tools, and we cover all of this. Walls, grids, levels, curtain walls, finishes, materials, ramps, stairs, railings. And then the second part of the class went into the documentation and the data management. So we went to shared coordinates, topography, parameters, two-dimensional components, drafting views, working with CAD, phasing, sheets, work sets. And I usually give 2 classes of Family Editor, but I'm just gonna compress it in one today. There are advanced topics that we were not able to get. I mean, we don't have infinite time, but some of the advanced content is creating custom families or custom content that it's based on a specialty type of families. For example, like level-based families or wall-based families or door families or generic pattern-based families, which is a very cool concept I would love to show in the future how this works. Or adaptive components, which is also a different animal. The other part that we did not cover, and let me just open a blank project, is things that relate to clash detection or clash avoidance, which are all the tools available here under the coordinate interference checks. We also, under the massing and site, the conceptual massing tools, it's something that we did not cover. We did topo surface, but there are parts of the topo surface that we might have overlooked, like parking components and property lines. But then for the rest, for the most part, we cover almost everything. Obviously, structural things are things that only the basic things like columns. And then all the analytical tools is another thing that we missed. Energy analysis, solar analysis, lighting analysis. There's this directional flow toolkit, which allows to find a shorter path between 2 points, which is good for doing code analysis. And then there's a plethora of different add-ins, for example, issues for BIM 360 docs or point layout, BIM interoperability tools, etc. But I think I'm pretty much confident that, I mean, with everything you learned this summer, you may be able to navigate, at least at the basic level, through any Revit project with some confidence. And if not, you can always go back to the recording or send me an email if you have any questions. All right, so let's see. I just saw Negar coming in. I'm going to paste again the link of the data set, so there's a chance to pick it up there. All right, and let me, oh, and the other big part that I think I did not cover, it's the computational design visual programming, which is Dynamo. And Dynamo, it's a visual scripting interface that allow you to create a custom script that manipulates Revit objects and access the Revit code. The Revit code is called Revit API, and allow to create scripts that expedite the creation of elements in Revit. And there's another subset of tools associated with Dynamo called generative design, which is the ability to create optimization studies that present the designer with multiple design options and hundreds of design options based on a set of inputs and outputs that we predefine. Examples of generative design are, optimization of the building layout based on sun, direct sun, or the creation of parametric facades based on pattern. And there is a very nice webinar that I just made, that I just delivered a couple of weeks ago. If you guys interested, I'll put the link in the chat panel. Let me get at it. So that you get a sense of what generative design is. It was one of our most popular webinars in the past few months. Generative design for Revit. Let me know if you can check, if you can see that recording. All right. And okay, and so all those topics are topics that I would typically cover in an advanced course. But let's talk about the content for today, and its family, the creation of custom families. All right. Any questions so far about content? Last day, any custom requests? All right. Let me put this here. I'm going to put this on the display here. All right. A family. Let's review the basics. A family, it's a collection of objects that share the same properties and the same parameters and the same behaviors, but and the same physical representation. And we learn the process of loading component families into the project. Remember, when we load a family, we're loading a file with the extension RFT, and they are loaded into the project, and then we place it into the project. What we created some families during the course. If you recall, we created some profiles, and we created, we access and modify some of the tags, and we open the families to explore how they behave. But we never really created a geometrical family from scratch. And so when we create a new custom family, we actually need to load a template that assign the category and the category parameters associated with that. So Revit ships with a lot of these families, templates. And the process of creating a new family, the first step is understand what is the category we want to create it to. And so on the screen, you have the list of all the templates in Revit. And you could create a wide range of different category types. Not all the categories are represented here, but inside Revit, we have a way to change categories in the family and the family types. I'm going to show you in a second. So the other thing is let me navigate here to this thing here. The content creation and the geometry creation inside Revit families, it's a little different from the one we see in the projects. I mean, the content in the project is based on categories. You create a wall, you create a curtain wall, you create a beam, structural elements, columns, etc. But in the family editor, we are presented with a solid editor. And the solid editors are ways in which we can create forms or form shapes. There are 5 types of forms we can create. We can create extrusions. All of these ways of creating forms are based on profiles. So extrusion is a two-dimensional profile extruded along a perpendicular direction. We have a solid blend, which is the extrusion between 2 different profiles. A solid revolve, which is a profile revolved around an axis. Sweep, which is extrusion along a 3-dimensional path. And a solid sweep blend, which is extrusion along a path between 2 different profiles. So in the process of creating these forms, you have to define the work plane that hosts the profile, because that's going to determine the direction. For example, the solid extrusion could be, those red lines you see below the solid extrusion are hosted by a work plane. And those work planes can be horizontal, vertical, on a slope, etc. And with these 5 operations, or 5 different methods of creating a solids, you can basically create almost anything. The other, it's the void massing tools. Voids, it's a way to create a solid representation that cut another one. So the modeling process is exactly the same way as the solid ones, except that when they are in contact with a solid volume, it will cut that it will cut that geometry. And so the combination of solids modeler and voids modeler give you the ability to really create almost any type of family. And let me open very quickly one family, again, in the link of data sets that I provided to you, which I already downloaded. I'm just going to open one of the families there. So it's family creation, and there's a toaster family here. This is a very detailed model of a toaster. And this big element that you see here is a representation of a floor. This is a floor-based family. And what that means is that every time you bring this model into a project, it's going to look for that floor surface in order to attach to it. This element does not travel into the project. It's just like a system or representation of what the surface might look like. And then if you look at it very closely, it's full of a lot of extrusions and it's super detailed. And it's made of a lot of different solids. At the basic level, you have the extrusions. I'm selecting this button, for example, and when I edit the extrusion, you can see it's just a profile perpendicular to the direction of the work plane, and the work plane is this vertical surface. There are also some extrusion blends, which is an extrusion between 2 different profiles. And so when I edit this, I have access to the different profiles. There's a profile at the base, and then there is a profile at the top. And then we using the Revit modeler, we determine how far the extrusion goes. Right now it's 5/8. We can do this like, let's do this a -1, and that's going to increase the size of that extrusion. You can also just pull those handlers. I'm going to do, because I don't want to change the original ones. Then we have these other ones. When I edit the sweep here, this is a sweep. Remember, a sweep, it's a profile along a path. This is the path. The path is hosted in a work plane. And the thing that you see here is the profile. And the profile goes 360 degrees around the path. You can edit the profile, and you can actually change it. You can increase the profile. And in turn, this is going to change the size of the handle. I'm going to do this, but that's this is what a sweep will look like. I'm going to cancel here. And then you see these pieces of loaf of bread. They are exactly just extrusions that are rotated, and they are placed along a work plane. And I edit the extrusion. That is the shape of the extrusion. The profile, it's hosted by a work plane. The work plane is at an angle, and then it has a thickness in a material. And the material is called toasted bread, which actually make it render like it has some bread on it. There are also, I don't think we have sweep blends here. Let me see if I see this. No, these are just typical sweeps. Again, another one. This is a profile hosted by a work plane and extruded along a 3-dimensional path. Both the profile has, no, this is the other condition. The profile has to be perpendicular to the path. And you see there is a condition here that displays the toaster in in a coiled condition and an expanded condition. And all that is driven by these parameters. So when I switch to fine, I'm able to see all the details. And when I switch this to coarse, then I see less detail in the extrusion. This is just an example that display, the amount of work that you can do to model something that is a little very intrinsic. Well, let's close this and let me show you the process of building something like that. Okay, let's start here. This is a review. All right, the family editor, it's a program running behind, it's like a program nested inside Revit that allow me to create custom content. The models, all the tools are different from the project. The main differences is that we have a solid editor under the form panel. These are ways to create shapes or forms. This button here is called the family types, and this is used to associate the family with certain categories. Sorry, the one above is the family category and parameter. This is the one that allows me to associate the family with specific category. And this is a way to create family components or family types. So this is the type editor and allow me to add additional members to the family. I can create all these 5 types of forms and an equal number of voids. If you click this drop down, you're going to see the 5 different ways of creating forms. And then under the annotate tab, we have something called symbolic line, and a symbolic line, it's a representation of a line that only display in projection views, meaning it's only visible in floor plans or elevation of sections that are perpendicular to the object. Symbolic lines are not visible in 3D. When do you need symbolic lines? When you want the construction documents to represent a symbolic appearance of a family, but not necessarily a geometry. An example of a symbolic line, it's the under the projection of a cabinet in a work plane. I mean, if you're doing kitchen cabinets are represented as dashed lines. And those dashed lines, are not three-dimensional lines. They're only visible in projection views. So symbolic lines enhance the symbolic representation of the family in projection views, in plan views. There's something called flip controls that allow me to mirror the component in the project, and you can do it horizontal flips or vertical flips. And then in the world of families, everything is about the references. The reference control the location of the profiles, and the profiles control the direction of distribution. So we create a lot of different reference planes in different directions. All right, so let's review the process. Sorry, I don't like these animations. I did a long time ago. But the first step is to pick the family category and select the appropriate template. If the category is not in this list, you can go into the, and let me go back here. You can go into the family category and select the category that it's available. When you click the family category or this button inside the family editor, it displays the list of all the possible categories in Revit. So if the categories, if you don't have a template for that, I'll give you an example. Let's say you want to create a component that is associated with the equipment. Equipment, it's a new, it was actually, it's a new category in Revit 2022, and there's no template for that. But if I go to that button, I'm able to swap the family from one category to another category. And the template load the family with appropriate category specific parameter. Then we create reference planes. And the reference planes is the framework of the family. It's like the skeleton of the family. It allows is like the part of the geometrical part of the family that allow it to assign actions or assign movement. Reference planes are displayed in projection. You won't see them in a 3D view, but it's very important that we name them. And reference planes have, there's a list of predefined identities for reference plane. You can choose what is the side that it represents in the geometry. So you're going to find like 8 or 9 different identity data. For example, front side, back side, top side, bottom side. Or you can override the name with a custom name. But reference planes that have a strong presence, they really need to have its own name. Then we add like the muscle. The muscle is the dimensional constraint that allow the family to be parametric, and that it's driven by dimensional parameters. So the dimension, this dimension of 2 feet, those dimensional constraints are converted in parameters. This is converted into the width and the height. And then that is a parameter that we can change in the project. This is an example. That's step number 4. Create and assign dimensional parameters that allow me to assign behaviors. So these parameters, which are also called labels, you can create them under the drop-down list of the label drop-down list here. And then you can come up with your own parameters. Some templates come with default family parameters, and the family parameters are the default parameters associated with categories. For example, if you start a family using the furniture template, it will come with the width, the height, and the depth. Those are family parameters, and they come with the template. You cannot delete family parameters. Okay, so we assign actions, or we create parameters to dimensional constraints in order to define a behavior. And the behavior, it's a custom parameter associated with a specific type. And then we flex the family. In flexing the family, it's checking that the dimensional constraints are working according to plan. So changing the parameter value of the labels, it's what means flexing. Flexing is, let's see if things work. So these are the 5 basic steps to create a basic family. We can add additional enhancements to a family, and those are the next steps. And we're going to do all of them in an example. We enhance the family with 2-dimensional or symbolic line work. Symbolic line work, it's a way to represent to enhance the representation of a family in projection views. They assign a type of line work, and it's usually connected to a subcategory. You can lock the symbolic lines to reference planes so that when the family is flexed, the symbolic lines also changes. Then the last step is to build the solid, and we use one of those methods that I presented earlier: extrusion, sweeps, revolves, and sweep blends to create the mass of the family. So these solid geometry is usually locked to the reference planes. We can assign geometry to different subcategories, so we control the visibility in the project. And we can create additional visibility parameters. We can create additional, for example, we can create materials associated with a specific part of the geometry. We can enable or disable visibility, just no parameters or formulas. And finally, we set the family to be displayed as certain views. Depending on the objective of the family, you may want to see it in plan, but maybe you don't want to see it in section or elevation. An example will be, let's say you guys do a lot of equipment. Maybe the equipment looks good or looks with all the details in elevations. When you see it in plan, you just see a box. So the box are symbolic representation, visible in plan. And then the full geometry is only visible in front, back, left, right, but it's not visible in the plan view. All right, let's do a family from scratch. And we're going to review this process one by one. So I'm going to have my PowerPoint running in the background. I'm just going to return to this slide. Let's go. We're going to create a parametric table, which is a super simple family to create. And we're going to start the family with the generic model template. All right, so in Revit 2021, let's start a new family from scratch. And in the family templates, look for the Imperial. And all these files have the extension RFT. And RFT stands for Revit Family Templates. And so I'm going to select the generic model, which is the simplest one. I could also start with the furniture, but the furniture comes preloaded with some system parameters. And I want you guys to understand the entire process. So I'm going to start with the generic model. I'm going to hit open here. So this is the family editor. And as you can tell, the create tab, it's different from the project. And all these tools are new to you. And then you're going to see that there's a family browser preloaded with some floor plans, elevation sections, well, just elevations. And there's a ceiling plan. And there, right at the center, there are these reference planes. These are the origin reference plane. And the intersection of these two reference planes is the origin. I cannot select it because I have the select pin elements disabled. And now when I select it, notice the properties of this reference plane. A reference plane has a name, center from front back. And he also has this checkbox that says this is the reference plane that defines the origin. The same is true for the other one. This is a reference plane. The name of this is left, right. And it has a checkbox that says defines the origin. And that means that the intersection of that with this one is the origin. You can change the origin of a family if you want to. You can make it be the front of the family or the back of the family or the top of the family. You decide how you want to do it. So I'm going to sketch what we're going to do with the table, and then we're going to do it. So let me turn this off. All right, so this is going to be a table. This is a table looking from the top. The origin is going to be the center of the two reference plane. And then we're going to create a table that has a width and a height and a depth. This is going to be the width, the depth, and then we're going to have a height and elevation. And these are going to be parameters that are going to control the different sizes of the different types. The table is going to have 4 legs using circular extrusions that start from the bottom of the level plane all the way to the underside of the surface. And the center of the leg to the edge of the table is going to be 3 inches all around. And so in elevation, you're going to have this table, the legs extruding up, and then the 3 inches are going to be from here to here. And we're going to create 4 different types of tables. We're going to have a leg material, and then we're going to have a tabletop, a countertop material. Now we can be as parametric as we want. For example, I could decide to create each of the legs to be parametric. Like I could make each leg to have a parameter called R and make it all respond to that. I could also create a thickness of the table to be a parameter. And I could also, but that is too much for this class. But you have that option. Now, if the thickness is something that's important to you, or the diameter of the legs is something important to you, definitely you have to include. So there's a process of planning the family. First, you have to understand what is the objective of the family. Do you need the family to be represented in greater detail in elevation, plan, and 3D? Or do you just need it to have a generic idea of how it looks in floor plan? That is going to determine the amount of effort you're going to put in the family. Then you need to decide what are the parts of the family that needs to be part of the schedule. And so remember the shared parameters. So if you want these parameters to travel into the project and be able to be part of schedules, then we need to add shared parameters into the family so that you can also schedule them in the project. If you don't need them to be scheduled, then don't use shared parameters. Just create the parameters inside the family editor. And so then we need to also decide if the family will need different levels of resolution. Meaning, does it need to look photorealistic? Then we need to add materials. If it doesn't need to be photorealistic, we don't add materials at all. So the purpose of the family is going to guide the amount of effort you place in the modeling process. So I'm going to make it fully parametrical. I'm going to add materials for the legs and the countertop. And also, and I also going to add a flip control. so that I can mirror it in any direction I want, either on the vertical or the horizontal. All right, this is my rough sketch. On your end, when you start a new family, sketching is always a good way to get started. All right, so let's go back to my process here. Now, the step number 2 is to create reference planes to build the skeleton of the family and give them the appropriate names. The reference planes are going to go in the floor plan and elevation. All right, let's do Revit. I am in the floor plan, and notice how Revit has all these predefined views. First, I'm going to create a reference planes to the right, another to the left, the back, and front. So under the Create tab, pick Reference Plane. Not to be confused by reference line. We don't want reference line. We want reference plane. The shortcut is RP. You can just type it on the fly. RP. I'm going to write this down because we do a lot of this. RP is the shortcut of reference plane. Okay, so this is the reference plane on the right. And you see where it says click to name. That's exactly what we're going to do. We're going to, actually, I'm going to use one of the predefined names in the family editor. You select the reference plane and you know it's on the right. So in the identity data, in the ease reference, pick the right and name it right. So the name is useful because when I create sub-elements, I can use these reference planes as working planes. If it doesn't have a name, it's not visible in the drop-down list. So you have to force the visibility of the reference plane in those drop-down lists by giving them a name. All right. Then again, RP, reference plane. Make sure it's 90 degrees pointing up. And I'm going to call this, this will be my left. And so you select then the reference plane and associate the reference plane to the left. Again, RP, reference plane. And this is going to be the back. And this is going to be the front. And I go back, give it the name to the back, and associate the back with the ease reference back. And then go to the front, give it the name front, and associate the reference plane with the strong reference plane. Front. All right. These parameter, it's important to understand. This is reference. Is reference. What it does, it's build a snappable surface of the component in Revit. So let me show you what is a snappable surface. You don't have to do this. I'm gonna create a new project. And then I'm going to place in the middle of the project one of the families that ships with Revit with a template. So under the furniture, I'm going to grab a desk and put it in the center. Again, you don't have to do this. So when I start placing dimensions, you see that blue line, these blue lines that appear, those are reference work planes. And what that means is that those are snappable surfaces nested inside the component. And so notice how this component has several reference planes. And what's good about this is that these reference planes allow me to align it with others or to place dimensions. So from here to here to here, that is a dimension placed between these explicitly defined reference plane. And when I open this family, and notice how in the floor plan, I have these reference planes, and these are strong reference planes. They are declared as references ones, and they create a snappable surface in the project. If I choose this to say none or not a reference, that behavior will not be present in the project. So I'm just do this example. I'm going to select all these four, and I'm going to declare them as not references. And they have a purpose for the family, but they are not going to define a snappable surface. So I'm going to load this into the project, and notice how now that I create a dimension, you see how it doesn't appear anymore. I have no way to play a dimension because I disable the reference plane ability to be snappable. So I'm going to close this. This was just to demo what that parameter means. I'm going to close as well this family. And we are in the process of creating the family. And so I am declaring these reference planes as strong references in this predefined list. Okay, then I am going to, any question? All right, then I'm going to switch to the elevation, the south elevation, or the front elevation. And I'm going to create a reference plane. Again, I just type on the fly, RP. And this is going to be the top of the table. I'm going to go back to the floor plan, and I'm going to start placing parameters. So this family is going to have a width, depth, and height. So I'm going to create a new dimension. We are here on the process. I'm going to add the dimensions, and then I'm going to create parameters associated with the dimensions. So I'm going to do step 3 and 4. So I'll create a dimension. That's going to be my width. And don't worry about the value. We're going to do that later. And then in the elevation and the front elevation, I'm going to also add another one. All right, so let's return to the floor plan. I have 3 dimensions in the family, and I'm going to associate the dimension to parameters. And that is the process of adding labels. So you select the label in the horizontal, and then you see this little button here. This is a way to create a new parameter based on a dimension. You have to select this first. Select the dimension, and we're going to press create a new label. It's this little icon that looks like a calculator with a little star. And this is going to give me access to the family parameters. This is how we create a family parameter. And notice that the interface is somewhat similar to the project parameters, but it doesn't have the panel that associates to a specific category because we're inside of a parameter. So read what it says here. Family parameters cannot appear in schedule or tags. This is important. So if your requirements tells you that you need to schedule this parameter in the project, then we need to associate with a shared parameter. And we look at shared parameters before, but I'm not going to worry about this. I'm just going to stay with a family parameter. And I'm going to call this width, and it's a type parameter. These two values are automatically associated, and it's going to be, I'm going to group it under the dimension groups. I'm going to do the same for the depth. So you select the dimension, and again, go into this little button in the label panel, which is create a new parameter. And I'm going to give this parameter the word depth. And it's going to be a type parameter, and hit OK. And then I'm going to switch to the elevation, the front elevation. And I'm going to add a new parameter. And this is going to be called the height. So go to the create parameter button and create a family parameter of the, and it's going to call height. All right. So I have 3 dimensions and 3 parameters. And right now, to display where the parameters are, you can open this button here, the family types. This is the family types. And the family types display parameter values. And it's also used to flex the family, which is the next step. So when you click family types, you're going to be presented with all the 3 parameters that I created. These are random values. And notice if I change this to 4 and hit apply, this is the process of flexing a family. But notice how things don't flex according to the center of the family. So I still need to work the family and apply dimensional constraint that allow me to flex the family from the center of the origin. And so I'm going to create a string of dimensions and click the equal sign to make the location of the reference planes at equal distance from the origin. So the way to do this is you go to the align dimension at the very top and create a string dimension using 4 points. 1, 2, 3. And I'm going to place this right at the top. That's the 4 point. And when you see the EQ, it's going to equidistance the location of the reference planes from the origin plane. And we're going to do the same in the depth. You go 1, 2, 3. Oops, what I'm going to do. Align dimension. You can also find it here. 1, 2, 3. Then you place it and click the EQ. And let's flex it. So we go back to the family types. And let's flex the width and the depth. So the width, if I change the width to 4, notice now the family, it's changing relative to the center plane. And that's exactly what I was going after. And the same is true for the depth. This is 3, 4, 5. So notice also the order of the parameters. The order of the parameters are based on, are alphabetically. So that's why you have D, height, and weight, and width. Now, maybe I want a different order. And I think this was a new feature 4 or 5 years ago, where you can move the order of the dimensions in the family types using this button, move parameter up. So in this case, I'm going to select the width. I'm going to move the parameter up so that I have width, depth, and height. And that's the order of my my parameters. And you can only change it within the group. You cannot change system parameters. For example, I guess all of this can be moved. Yeah, like the cost, I can move it up if I want to. Okay, so this is, I created the framework. I still need to take care of the elevation. Just hit OK here and switch to elevation. I'm going to switch to the front elevation. And in the height, again, oh, it's already, I'm going to just flex the height and see if it's working. So this is 4, 3, and it's working. So, okay, so I have my basic geometry here. I'm going to go back to the family types and leave the default values to 5 by 5 and 3. The square table. All right, so this is where we at. We select the appropriate template. We pick the generic model. We create and named the reference planes. We change the reference plane ability to be snappable in the project. That is the isReference project. We added the dimensions. We associate parameters with those dimensions. And then we flex the family for each of the parameter. Let's do the next steps. So we need to add two-dimensional or symbolic line. In this particular table example, I'm not going to add symbolic lines, or maybe, yeah, let's do one symbolic line. Let's say that this table needs to have symbolic lines that look like an X. So I'm going to go to Revit and I'm going to add the symbolic line. So you go to the Annotate tab, add symbolic lines. And these symbolic lines are going to do this X. Escape to finish the first segment. And then another one to finish the other segment. These lines are symbolic. They're not going to be visible in 3D. They're just going to be displayed in plan view. So why symbolic lines? It's to enhance the representation of families in construction docs. I'm just going to leave it like that and then continue. Now I need to take care of the, before I do this, let me undo this. I need to take care of the legs. So the legs are going to have a center point 3 inches away from the edge of the table. And it's going to be driven by 4 additional reference planes. So let's define the center of the legs first by adding reference planes. So I'm going to do RP here on the fly, RP, and then another RP offset of the reference plane, another RP here, and another reference plane there. So I created 4 additional reference planes offset inside the outer countertop references. And then I need to force these distance to be 3 feet. Now, the other thing I'm going to do is make sure that these reference planes are really not references, because you really don't need to snap or create any snappable behavior associated with the legs. So these 4 reference planes that I just created, I'm going to disable their ability to be snappable. So I'm going to say not a reference. And I'm going to do for the rest of the reference planes. I'm clicking Control to select the 4 new references, and they are not going to be snappable word planes. All right, so this is going to be the center of each leg. I'm going to add circles. The circles are going to be hosted in the level, and then they're going to extrude to the underside of the table. Now, I need these behaviors to be 3 inches away from the edge of the table. So I'm going to create a dimensional constraint on the front end, dimensional constraint on the right end, and a dimensional constraint at the back end, and a dimensional constraint on the left. So all of these needs to be 3 inches, right? So I am going to select the inside reference plane and change the dimension to 3 inches, 0.3. And this is a big table. Maybe 3 inches is a little too narrow. Let's do it. Let's do 4 inches. Let's do 6 inches. 0.6. Yeah, that looks better. And once you get to 6 inches, lock it. And locking a dimension creates a dimensional constraint. The lock, it's dimensional constraint. And what that means is that distance is always going to be 6 inches. So select the dimension and mute it, and lock it. Select the dimensions and change the value to 6 inches and lock it. Select select the reference plane, and again, remember, you don't want to select the outer reference plane. You want to select the inner reference plane, because that's the one you want to change. And select it and lock it. Select the dimension and lock it. And lastly, select the reference plane. Select the dimension and lock it. Oh, I need to change the dimension to 6 inches. select this to 6 inches, select the dimension and lock it. So I have 4 different dimensional constraints, 6 inches away from the edge of the table. They all are locked lines, locked reference plane. And let's flex it. Let's see if this works. Access the family types. And let's change some values. I'm going to change this to 4. And look how the dimensional constraint is kicking in. It doesn't matter the size of the table, the offset it's respected. And I'm going to return the final values to 5 feet. Hit OK. And I think I'm done with the reference planes and the dimensional constraint, except the elevation. I need to go back to the elevation and define the countertop thickness. So any question here? All good? All right, so I'm going to switch to the front elevation and create a reference plane below the top of the surface. So again, create tab, reference plane. You can just type on the fly, RP. And I'm going to create a dimensional constraint. This is a dimension under the dimension tools. Then select the dimension, select the reference plane to change the value of the distance. Remember, in Revit, in order to change the dimension, you have to select the object. When you select the object, this turns blue. So select the reference plane and change this to 2 inches. And this table is going to be 2 inches in thickness across all the families. I could make it a parameter if I want to. I'm not going to do that for simplicity, but I'm going to make sure that no matter what the height of the table is, the thickness always remain as 2 inches. So I'm going to flex it with several values, and notice how regardless of the value of the height, the thickness remain as 2 inches. So I'm going to return it to 3 feet. And I think I am ready for the next step. So the next step was to create the symbolic lines, which I deleted. But I am going to do that now. Let's say, oh, here's a good example of the use of a symbolic line. Say that from the top of the view, you want to see the location of their legs as dash lines. So each of the we can create reference planes. We can create symbolic lines that represent that. But we're going to add that at the very end. So let's move to the next step. Now we need to build the geometry, the bulk of the geometry. And the geometry build automatic association with the reference planes. And let's make sure that we assign the geometry to the appropriate subcategory. All right. So in my project, I want to control the leg visibility and the countertop visibility using different categories. So subcategories are things you can create inside the family editor. And you'll do that under the Manage tab, Object Styles. Object styles, remember, control the global visibility of objects inside Revit. And notice that by default, this template has only one subcategory, and it's called Hidden Line. So I'm going to add, again, the way to get here is you go to the Manage tab, and then you go to Object Styles. So I'm going to add a couple of subcategories because I want to control the display of these objects in Revit using visibility graphics. And so I'm going to add something in the subcategory. I'm going to add legs. And then I'm going to add another one called tabletop. Tabletops. And these subcategories are going to travel into the project, and they are going to be visible in visibility graphic overrides. So you could potentially apply in the project different visibility, different line weight value to the subcategories of this object. You can also create line types or line. For example, if you were creating a door, you definitely want to create a subcategory for the glass, a subcategory for the panel, and a subcategory for the hinges and all the hardware, so that in the project you can selectively display things on and off using subcategories. So I created this couple of subcategories. You just hit new to add more, or you can delete them or rename them. And apply this and hit OK. So let's start with the tabletop. So the tabletop, it's going to be, I need to go to the front elevation. And I need to give this reference plane a name. Why? Because that's the work plane I'm going to use to host the extrusion. So in the front elevation, select the reference plane and give it a name. I'm going to call this bottom of the counter. All right, just by virtue of giving it a name, is going to be a work plane available for your use. So I'm going to go back into the floor plan, and now I need to set my work plane. This is important because the work plane is going to host the profile of the extrusion. If I do it right now without setting the work plane, the extrusion profile is going to be hosted at the ground level, which is the default work plane. So under the Create tab, we're going to set my work plane. And remember where I say work planes is everything in Revit. I'm going to set the work plane, and I'm going to pick the bottom of the counter. If your work plane does not have a name, it's not going to be visible in this drop-down list. And that's why it's important. Always name a work plane so that it's available in this drop-down list. So I'm going to pick the bottom of the counter as the host of my profile lines, and then I can create the extrusion. So the extrusion is a profile. The profile has sketch lines. The sketch lines are placed in the work plane, and then you select a dimensional extrusion distance from perpendicular to the view. So under the Create tab, I'm going to pick the extrusion. The extrusion work plane, you can see it right here, is the bottom of the counter. So it's in the right location. And to make it easier, you can use a rectangle. That's the easiest way of creating a rectangular table. Pick the rectangle tool in the draw tools and snap from the upper left side to the lower right side. And notice these snaps. There is a snap action right now to the grid line. And you can see because there is an X here. And it says intersection. And then you see these two things in blue. When sketch line snap to point intersection, it creates an automatic lock with this work plane. And that's where you're going after. You want this sketch line to always be aligned with the front, with the edges of the table. So I'm going to snap to intersection, and those locks there that appear, there's no need to lock them. Again, if you snap to grid line intersection, it creates automatic relationship with the work planes, and there's no need to add additional locks. All right, so I'm going to do the green checkbox here. And then let's flex it and see if it works. So if I change my width to 4 and my depth to 4, notice how the size of the table also changes. I'm going to return it to 5 feet before. Then I'm going to move to the front elevation, and this is the extrusion size. And notice that it's 1 foot in height. That's not what I want. And what I'm going to do, I'm going to force this extrusion to align with the top of the reference plane and lock it. This time I do want to lock it. I'm going to establish a lock relationship between the top surface and the top work plane. So just grab this handle in the elevation and snap it to the reference plane. And this time I do want to lock it. And let's see what happens when I flex it. I flex the height to 4. Then the whole table moves up. 2. I'm going to stick with 3 and hit OK. Go to the floor plan again. And I think my top surface, it's working pretty well. I flex it both in the 3 dimensions. All right, let's build the legs. For the legs, I need to switch the work plane to the ground level or the reference plane. And it's gonna start from the bottom of the plane to the underside of the tabletop. So first thing is to set the work plane. So you go to the Create tab, Set, and in the drop-down list, you want to pick the reference level. Every family has a level. The level represents the ground level. And this is going to be the work plane that's going to host the extrusion sketch line profile. Then you hit OK here. You don't notice the change because we are in a floor plan. And now I'm going to create extrusions. And I'm going to create all the legs in a single step. And all the legs are going to have a radius of 1 inch. So you go to the extrusion tab with extrusion tool. This takes me to sketch mode. And I'm going to create circles. So I'm going to create a circle to the intersection of these grids and a diameter of 1. You can just type on the fly 1 or 0, 1. 0, 1. And continue. Go to the next one. Another circle at the intersection of this grid. Snapping to the intersection is important because it anchors it creates dimensional constraints of the circle with the reference plane. So again, I'm just going to type on the fly 0, 1, and then go to the next one. 0, 1, and then go to the next one. 0, 1. So I have 4 legs. The purple lines, which are the sketch lines, are hosted by the ground level. And right now they have an extrusion of 1 foot from that work plane. We can change that dimension. But we can do that at the elevation. And then we're going to hit the green checkbox here. And let's see if this flex. So under the family types, I'm going to flex the family, the width and the depth. And notice how the legs also flex with the family. And the reason it's doing that is because I really snapped the center of the circle to the intersection of the reference plane, which create an automatic dimension. I'm going to go to the front elevation. And notice how my legs are short of height, because I actually need to snap the height of these legs to the bottom of the counter work plane. So what I'm going to do in the front elevation, switch to the front elevation, is to select the legs, and you see the handle right in the middle. Click on the handle and snap it to the reference plane and lock it. This time I do want to lock it because I'm not snapping to any intersection, and I want to make sure that the leg height flexes with the changes in the height. And you can test it. Let's flex it. In the family type, I'm going to change the height to 4, 5, 3. I'm going to return it to 3. And so I literally have all my components in place. Return to the floor plan, and I think I am good to go. Let's let's build the symbolic lines. Remember, the symbolic lines are ways to enhance. If I bring this family into the project, I'm not going to be able to see the legs, and that is expected. But let's say that for some purpose, I do want to see a representation of the legs from the top view. And you can do that with symbolic lines. So the symbolic lines are going to be hosted by the top plane, and it's going to be we're just going to be tracing over the circles. So we're going to create. First, we have to set our work plane. our work plane, it's going to be the top. And I don't think I have a name for it yet. You see the importance of naming reference planes. I'm going to go back, I'm going to cancel this and go to the front elevation, select the top reference plane and give it a name. This is going to be the top reference plane. And then I'm going to go back to my floor plan and create 4 symbolic circles. So you go create, set, and set my top reference plane, which is the top surface of the table. And at that elevation, I'm going to create a symbolic line that displays circles for each of the legs. And all I'm doing is snapping to the intersection and snapping to the leg diameter. And by virtue of snapping to the intersection, then it's locking its location relative to those reference planes. So let's flex it. I'm going to flex this 4x4. And notice also that the symbolic lines move with the geometry as well. You can look at it as well in 3D view. So if you click this little default 3D view, notice how the symbolic lines don't travel in 3D. They are only going to be visible in floor plan. And here you can also flex the whole family. 3x3x2, 2x2, and I'm literally creating different types. So I'm going to stick with 5x5x3, and let's see what's next. So after I create the solid geometry, I could add additional parameters. So we could define parameters for the materials. We can create yes, no visibility. We can have formulas. And we can assign parameters to the 2D or 3D geometry. The parameters I'm going to add here are materials for the leg and materials for the countertop. So yes, we're going to create a leg material and a top material. So in this example, I'm going to add 2 more family parameters. One is going to be called leg material and tabletop material. So hit the family types, and I'm going to create a new parameter on the fly here. These little button right here, it's a way to create new parameters, create new parameters. And when we create a new parameters, we need to define whether it's going to be instance or type. If it's a type, all the elements of the same types are going to receive the same material. If it's instance, every single table is going to has the potential to have a different material. So just for fun, I'm going to make them instance, but in reality, more likely is you're gonna create tag parameters instead. So I'm going to add a new parameter. This is a family parameter, and the name is going to be leg material. And the leg material is going to be a material type. So it's going to report material. This is important. When you select material, then you're going to have a parameter value with those 3 little dots that's going to launch the material library. And we're going to automatically put it on the materials and finishes. And it's going to be an instance parameter. Instance parameters inside the family editor are identified by this default in brackets. So default means instance parameter. It means this is the full value for the instance parameter. Notice how width, depth, and height are type parameters. They don't have the word default. So you can visually tell if something is instance or type just by looking at the default thing. And notice that because I selected the material as the format, it now allows me to access the material library. Now here's another tip. Do not assign materials in the family browser, in the family editor. The materials are best to be placed in the project because the project has a wide range of materials, and materials can change from project to project. So it's best to leave the material by category. And then when you load the family into the project, then assign a material according to the specifications of the project. And notice also how inside the family editor, there's barely any material, and you have to add additional materials in the family editor in order to load them into the project. If you create a new material in the family editor, that material is going to travel into Revit, into the project. But if the material exists in the project material is going to override the family material. So that's another tip, another note, things to know. Project materials override family materials. And that's why I'm saying it's best to assign the material at the project level. So I'm going to cancel here. I'm going to leave it as category, and I'm going to add another one. This is for the tabletop material. It's a family parameter, tabletop material. And it's going to be also an instance parameter, and it's going to be a material, a type, group under material and finishes. Instance material, material type. And again, just leave them by category. These are values that will be defined in the project. Okay. Let's go back to the list of steps here. I created additional parameter for the materials. And you can also assign parameters to 3D or 2D geometry. What does that mean? In complex family, you may choose to display certain geometry differently in different elevations. So the visibility settings in the project allow me to selectively enable or disable the visibility of these objects in certain type of views. For example, you may want to see them. I mean, in this case, the legs are going to be visible everywhere. I don't think there is a point or a case for not displaying them. But if you're doing like a complex equipment with a lot of details, maybe the details are only relevant for elevation, but they are not relevant for a floor plan. And so you can disable the geometry ability to represent in projection views. And you can also assign different granular type information to different detail levels. Remember detail level here? I remember when we switched from detail level, coarse, medium, and fine, it can display different degrees of information. Well, this is inside the family editor. This is how you assign the visibility of certain elements to display a different detail level. This table is super simple. I don't have a reason to apply or override a view specific display or a detail level, so I'm just going to leave it as is. But you can selectively say these legs are only going to be visible when the project is set to fine. Or you can say these are only going to be visible when you set this to coarse. It's up to you. I'm just going to leave everything enabled, hit OK. And then finally, I just explained that visibility settings. And the final steps is to create types. Flex the family and create types and load it into the project. So let's do the final steps. Now that everything is flexing, I mean, I've been flexing along the way. I'm going to create family types. Family types is to create the collection of members of the family. So under the family types button, this little button here is a way to create new types. Create new types. And the standard for creating types is disclosing or naming it according to the size in inches. In the case of tables, for example, you can, or feet, for example, if you can say 5 by 5 by 3. Or another alternate will be 60 by 60 by 36. I think the latter is more common than the first one. It's typical that you associate the type name with dimensional sizes. So let's do that. I'm going to add a new type, and I'm going to call this 60 by 60 by 36. So I just created my first collection. This is the first item in the collection. We're going to add another one. And I'm going to call this 60 by 60 by 24. And then after naming it, I change the height. It's going to be 2 feet. I'm going to add another one. This is going to be 36 by 36 by 24. And the dimensional constraints are going to be 3 by 3 by 2. Let's add another one that is not square. Let's do one that it's 36 by 24 by 24. 36 by 24 by 24. Let's do another one, 24 by 24 by 18. It's going to be 2 by 2 by 18 inches. And let's add one that looks more like a coffee table. So let's make it 48 by 24 by 18. So it'll be 48 by 24 by 18. And you can continue building your collection here. Very quickly, I just built 6 different types. You can create them right now in the family editor. Or remember when we were in the project, you can, once the family is loaded into the project, you can duplicate the type, rename, and change parameter values. All the materials are going to be assigned in the project, so I'm just going to apply here. And I am ready to load this family into the project. I'm going to save it. And I'm going to give it a name. It's going to be table. It seems to be flexing. I am just ready to load this family into the project. So I'm going to create a new project. from scratch. Imperial architectural template. And then I'm going to load this family into the project. The way to load the family is to go into the family itself and hit load into project. So I jump back into the family and hit load into the project, and that's going to bring the family. And I'm going to create 6 different instances. I'm going to switch. Notice this little circles. That's actually the symbolic line. The symbolic line is kicking in and it's allowing me to see the legs underneath. I'm going to switch to a 3D view, and then I'm going to enable shaded view, or better, realistic view. And then I can start swapping all the types and assigning parameters. So this is the 60 by 60 by 36. I can do this to 24 by 18. 36 by 24. The 36 by 36. The 48 by 24. And the 60 by 24. And the 60 by 60. All right, so this is the collection of my tables. And remember what I say, you can create additional types inside the project. Just go into the generic models, go to table, select a type, duplicate. Remember, duplicate, rename, and change parameter values. I want a table that it's a 20 by 20 by 36. It's a slim table. And then edit the type. Double click the type. And I change this to 20 inches by 20 inches by 36 inches. And I just created a new type based on an existing one. I drag it and drop it. And this is my slim version of a table created inside a project. I have not defined materials yet. I could bring additional materials if needed, or I can create new materials. But let's apply that. Let's turn off slowly. I'm going to select this one, and I'm going to say the leg material, it's wood. Cherry, and the tabletop is glass. Did it kick in? Yeah, it kicked in. Oh, you know what? I did not assign the material to the project, so that is a problem I have with the family, and that's why I need to flex it. So I need to go back to the family, and something I forgot to do is to assign the material of the family with the geometry. So this is the process of nesting a parameter inside another one. The legs, look at the legs material, it just say they are displayed by category. But this little button here, it's a way to connect, concatenate parameters. It's a way to connect the value of this material with a parameter created in the family type. So I click on this toggle and associate the material of the geometry with the leg material. And then I select the table and associate the material of the form with the parameter. Now I'm going to save this. I'm going to load it into the project again. override the parameters, and now the materials are kicking in. Let's do another one. This is going to have another type of wood as a top, and maybe it's going to have metal legs, aluminum legs. That's how it looks like. I can do another one. This one may have ceramic, maybe not ceramic, and the legs are going to have soft lumber. And so the materials are getting applied to every instance because they were instance parameter. And they're kicking in because I concatenate the value of the material with and again, here the leg materials, I'm going to make paint. Let's see if there's any paint here. All right, there's a parking stripe here. And the top is going to have another type of glass. All right. And I can continue going table by table, assigning new materials, and they're going to render accordingly to the material assigned. Yeah, so that is the family process. We flex the family, we define new types, we flex the family again, load into the project, and make sure that the family works. And I am seeing it in 3D, it works in Plan. In Plan, I also have the symbolic lines displaying the circles of the centers. And yeah, this family is now completed. So this was a very simple family, and notice how because I took the time to explain it, it took almost the entire hour to go through it. But as you get used to this, you can really build it fairly quickly. In organizations, they're usually, people who are really skilled at modeling that are able to put together families like this. So hopefully within your organization, you have a BIM content creator who can help you in case you stumble with families. But let me quickly show you some advanced families. And in the data set that I provided to you earlier, I provide you with some very detailed families. So you go to the, I'm going to go to the my D drive. In the family creation, there is this, let me show you this blackjack table. I'm just going to drop it into the project. These families are in the Google Drive. And I think that needs a face. This is a face-based material, so I need to have a floor. I'll create a floor here very quickly. And then add this family again. It should be on the furniture or generic model, this blackjack table. This was modeled by Michael Anonuevo, who was a contractor for casinos in Vegas. And these casinos created all the furniture in Revit. And all of this is a highly detailed family. made basically with extrusions and sweeps and voids. And this collection of objects were are made of nested families. For example, a chair, it's a family nested inside another one, and then it's arrayed in the family. So let me just open this family. You can select it and edit family, or you can just open it directly from there. And just to show the process that goes behind doors, this family has 4 different type of families. All of these are nested families. You can select this, add the family, and you can actually see how it was done. It's an array of extrusions along a path. I'm gonna close it. I don't need it. Well, let me open another family, just where this is so this pool table, which is also a highly detailed family, well hosted. The reason I like this is the amount of detail that goes into it. It's impressive. Like these legs are nested families. When you edit, it's just a collection of extrusions. You want to understand how it was put together. It was a sweep. A sweep. This is the sweep along a path, and it turns the right angle. And then it has all these voids that creates the reveals in the surface. And if you're doing like historical renovation for facade, this gives you an indication, you know, that you can really build a lot of crazy stuff in Revit. I think this idea that Revit is very limited in its ability to model, it's a little misguided. With the right skills, you can actually model almost anything. Anyway, I am giving you those families for your use. I don't know how often you're going to use a family like this, but it's fun to just dissect and understand the back process behind it. All right, so this is, I'm hitting the end of the class, so I'm going to close all these families that I've shown to you. Again, family editor, it's a task that somebody in your organization needs to be really good at to be able to create your own content. There is a lot of complex families that I would love to show. For example, create a custom door from scratch or create a new window from scratch. Those are families that are a little bit more elaborate or like fixtures. But if you're interested, please send Lana a request for an advanced class, and I'm happy to do a shorter version with all the mentioned advanced topics. So anyway, the recording is going to be available on YouTube. Feel free to practice if you fall behind. I'm going to leave the classes on YouTube for the next 2-3 months. And then after that, I'm going to leave them on until I get the next class. So I don't know if I'm going to be teaching on the fall. If I am not teaching on the fall, it will be there for the rest of the year until the next spring. But I'll let you guys know when I move them away from the public view into a private list, and then you can continue watching as a private as long as you have the password. So anyway, I think this is the end of the class. It went a little longer. I hope you guys find some value in the things I taught you. through the summer and enjoy it. I love teaching, and if you find me referrals for future people, I love to. The school, again, it only offers this class a couple of times a year, sometimes only once a year. But it's a good way to keep the program open and moving forward. So any comments?
Thank you, Cesar, for teaching. Appreciate it.
Yeah, thanks for staying with me all these evenings. And if there's no more comments, then I'll look forward cross paths with you sometime in the future. You never know how and when.
Thank you so much, Cesar.
Thank you very much.
All right, see you.
Great teacher.
Thank you so much, Cesar. Have a
Thank
good
you.
one.
Bye.
Everybody
Thank you.
has a great evening.
You too.
Okay.
You too. Bye.
Bye-bye.
Bye.
Bye. Have a good one.